My name is Pedro Gomes, and I'm the founder of Wallet Connect. And I'll be talking about session authentication for smart accounts. And in order to do that, I think we need to kind of break down the lingo, because in Web3 we talk about a lot of new terminology. But if you think about it, a lot of the terms are familiar, or at least the experience is familiar with what is the internet today. And when you think about connecting the wallet, we're basically just moving away from this login experience to a connect experience. But is it really that different? Even if you consider all of the actual terms that we talk about, from signing and accounts and keys and connections, but realistically, we're doing authentication, which is a very well-known term, and at the end of the day, you just need to verify you are who you are. And if you're a user and you want to use an application, authentication isn't necessarily the most fun part, because at the end of the day, as a user, you're just thinking, let me in. I just want to get in. I don't want to get with more steps. So I think it's important for us to define the mission that in order to have a good experience, less clicks is more. And that's essentially what we're going to try to achieve with smart accounts, but at the same time, we need to address why Web3 is different. And by understanding the concept of how the previous internet, to some extent, or the internet that the majority of the world uses, sometimes called Web2, you have this concept of a server and an application. And while the server has a lot of components, one of the most important components is the authentication part. And you can see in this diagram, a very simplified version, we have internally of the server a small service or component called auth. And in a blockchain or Web3 world, we basically moved that into the user's device, because we wanted to empower the user to actually have control over his data and assets, and we called it the wallet. And the wallet essentially is the module that actually allows you to authenticate into the blockchain, and the app is essentially waiting for the user to actually give permissions. So if you think about this, maybe we should break down what the wallet actually is, because obviously it was different than what we had before, and we can think of it as almost three separate concepts, where you have a set of credentials that allows you to actually get access to the wallet, which might vary from passwords and PIN codes or email, depending on which wallet design you're actually using. And then there's some form of signing, whether that's local software or hardware, or even remotely in a node. But at the end of the day, they all have this idea of an external account. And we want to evolve this into a smart account world. So we kind of have to explore how we actually use wallets today and how we can get to a much better experience. The way we actually log in or connect our wallets today is that we actually establish a connection between the dApp and the wallet, as you guys saw in the diagram before, but we then need to actually prove that you are who you are. And in order to do that, the standard sign-in with Ethereum was created to verify with a single message signature that you actually own the wallet that you're claiming to own. And this actually looks like this, which isn't horrendous, but it's still an improvement to what we had before, because before, some people were just signing random hashes or arbitrary messages that every dApp did differently. So with Sign with Ethereum, we created a standard to actually format and have a more consistent experience that actually feels somewhat familiar to the existing Google login or Facebook login. And you can see that essentially have a concept of some website or application wants to access your account, and there's some terms of services associated with it, and certain conditions around which chain, which timestamp, or when it expires. And we even have this concept of resources, which will eventually be useful for us to actually build a better connection experience, which we'll then get into that. At Wallet Connect, we decided that this idea of connecting and then signing a message with Ethereum, it kind of becomes a little bit of a nuisance, and we actually should reduce the steps. At the end of the day, less clicks is more, so having 2 steps already just to get into an application feels like a big hurdle that we should solve. So why don't we just scrape the connection part and skip it to the session? So with CAIP 222, which is a chain agnostic standard, so it would work for all the EVM chains and outside of it, we would have a single step where we can sign in right away without actual having a connection, but you're still able to establish a session with the application, but prove at the same time that you own that wallet. So that was already a big step, but is that enough? Because realistically, you also want to sign transactions. That's why we actually built this ecosystem around blockchains. You want to actually create some assets and data and actually change how the blockchain works, and signing transactions is the end goal. So most people might think, just close your eyes and approve, like, you know, whatever, like the pop-up shows up, like I'm so tired, I just wanted to get it done with, and that kind of like breaks the security, and it's quite a challenge, right? To build a good wallet experience, you always have to like balance convenience and security, and in order to do that, it's quite of an art, because the user at the end of the day wants less clicks is more. Like, this is why we're here, right? We want to have the best user experience, the user just wants to get it done with. So we need to kind of understand why wallets work the way they work, right? We already have the concept of a wallet, an application, and the blockchain, but why is the wallet so important in this component? It's because public key cryptography consists of two keys: the private key, which is the one that's secret to you as a user, and then the public key, which actually is available to everyone to verify that you own the private key. So these two are connected to each other, but only one of them is actually available to you. And what happens is that you actually have some message. And when I say message here, it could be anything. It could be a transaction or just a simple plain text message. And once you actually pass this message through like a cryptographic curve with your private key, you actually output a signature. And this signature is quite powerful because it validates not only that this message has been validated by you, but then they can actually compare it against the public key, which is publicly available, as it says in the name, and then verify that you actually intended to do something. But in blockchain, like obviously, it's not as simple as that simple diagram. You actually have some form of transaction that passes the message through the private key, outputs a signature, and then you have a public key that actually matches an account. Because it's also important to note that your 0x address that you see on the blockchain is not the actual public key, but it does match an account. So actually, what we can do is break down this concept that the public key always matches to an account and build a much better experience. And this is what smart accounts is all about, or more technically known as externally owned accounts, EOAs, converting into a smart contract account, or SCSAs, or let's just call it external account and smart account. Like, I want to keep it simple so that we have this experience, we want to move into smart accounts, and we're going to understand how we're going to get there. And a smart account is deployed by a smart contract. So if you have a smart contract, how can you actually sign? Because we just said that the wallet is essentially a private key. If you have no key, then you have no signature. So it's important that we actually create a standard for this, and fortunately, someone has already thought about that, and signature validation for contracts already exists with 1271, which allows you to actually sign with a key that has ownership over a smart contract and essentially sign on that behalf, and the contract will validate, yes, this key can sign on the behalf of this account. So we essentially decouple the signing into having multiple signers to then own a smart account. And this comes with a very simple spec. If you actually look at it, it's just a single method that literally calls isValidSignature. That was simple enough to actually solve a lot of problems, but we also have to kind of go a little bit deeper into what an account means. We broke down what a wallet is, but what is an account? And an account, you can think of it as a signer, a payer, and some cryptography. The signer that we just saw was solved with the 1271 because now you actually have multiple signers owning the account, which is validated through that method. And what we don't have is the payer. And this is something that the smart accounts can actually introduce, where the signer always pays for the transaction in an external account. With the smart account, we can break that relationship and have someone else pay for that. And an advantage, or almost as a side effect for this, is that because we decouple the signer from the payer, we also can use different cryptographic curves, so we're not like tied to the blockchain limitation of using this specific curve. We can actually use something that's more widely available in your phones, in your computers, or tablets. So now that we actually have this world where like we can have like multiple signers and wallets and applications, we also have the opportunity to kind of simplify it and just have for all users or all profiles a single smart account everywhere and kind of make a better experience. So what it actually means to be connected, when you actually connect to expose an account, you read some blockchain data because you're given an address and we can actually check the state. we create a session for you, which we validated with sign with Ethereum, and then we request user approval to submit transactions. So if you now have these multiple signers and you have payers, now we kind of need to standardize how these smart accounts work. And this is where account abstraction kind of took off. 43.7 was a pivotal moment for smart accounts because it standardizes this concept of multiple signers and payers, and it almost can be described with a simple diagram, which if you remember the triangle that we had before of app and wallet and blockchain, now it's a little bit more complex, but it actually can be simplified as a wallet requests a paymaster to actually pay for its gas, and then the signer would actually sign the operation, and then the wallet submits all of that to a bundler. And in 43.7, we introduced a new concept of a user operation. So remember how we actually signed with your private key a message? Before that message was a transaction. Now we shifted into a user operation. So now the wallet is delegating the payment to the paymaster, delegating the signer to a signer, and then we actually send all of these user operations to a bundler. And the reason it's called a bundler is because it takes a bunch of user operations and constructs a single transaction as a single bundle and submits to the blockchain. And now we have abstracted a lot of complexity, but we also introduced fragmentation because every wallet and paymaster and bundler will do something a little different, and we want to make sure that we still have the same interoperability that we had with external accounts. So the first problem that we have is how do you discover if a wallet supports smart accounts? Fortunately, we have 5792 wallet call API methods, which introduce 4 new methods. And in these 4 methods, we have a much better experience to interface with wallets. But most importantly, I would like us to focus on get capabilities, because this one is actually the one that gives a little bit more visibility from a dApp to say, this is a smart account. And something that we can do is actually, this is purely illustrative, but you could say, this supports session keys or paymaster service, and essentially gives the scope of the dApp what I can do with this wallet. It's much more than you could do with an external account. But then even if you found that, you still have to understand, does this wallet support paymasters? Which paymasters does it support? And how can you interface with these paymasters? So yet again, we created a new standard for that, a paymaster web service capability, which actually describes, let's not get into what it actually describes, but the most important thing is that all paymasters will follow the same API. And this, again, creates a more competitive and fair market for paymasters because you don't have vendor lock-in around specific paymasters, and instead you actually have all paymasters using the exact same API. And even if you do have that, remember how we actually introduced the concept of user operations? Those are different from transactions, and one of the differences is that the smart contract wallets will then actually do user operations very differently. So actually, for someone else to actually construct the user operation will be very hard. So with 7679, we have this concept of a user operation builder, where we can delegate to the wallet and say, I want to do this transaction, but I don't know how to construct the user operation, so you tell me how to format correctly. And this, a lot of code, I know, but if you look at it, it basically gives you the primitives to actually construct a user operation. So now that we actually standardize how smart contracts can actually interface with a user operation and paymasters, we have standardized a lot of things. But still, if you think about smart contracts today, they're more complex than just paying and submitting transactions. They also have concept of modules. If you think about safe modules, they have their own ecosystem, but then how can we standardize across the whole Ethereum ecosystem that's all modules work the same? 7579 introduces a solution to that, which essentially brings an even more generalized solution that everyone can comply. And we can think of modules for many different use cases around guardians and around key management, but I like to think even something as simple as recovery can be designed as a more competitive market with this standard. Now, you kind of think that we did a lot of work into breaking down the wallet into multiple components. We could almost embed the experience in a dApp. So why don't we just take the paymasters and signers and we bring it all to the dApp and we start signing user operations in the dApp? If we do this, we would be introducing the concept of session keys. And personally, I think this might be the most pivotal moment for the experience of Ethereum, because if you do have session keys, you can almost think of the wallet as its own purpose is to approve an interaction with a dApp and do a single click to sign with Ethereum. And yet again, we completed our mission to do less clicks is more. Not only we remove the connection part, we go straight to sign with Ethereum, but we can now actually improve it by not even having to go to the wallet to submit transactions. So to do this, we're currently working on an ERC that is pending having its own number because we're still working on it. But hopefully within the next days, we will start seeing how we can actually define permissions for sessions. And this will look very simply where you can actually request permissions from a wallet, and the wallet will ask the user, do you want to approve these permissions? And then once approved, it will allow the dApp to actually have this permissions object, and then it can use the permissions to send it directly to the bundler. So now, if the dApp can actually do everything by itself, the only thing you actually need from the wallet is the permissions. And if you remember when I showed that sign-in with Ethereum looks very similar to Google Login, in Google Login you also have a list of permissions that the dApp or the app asks from Google. We can have the exact same experience for Ethereum apps. So if we're going to give keys to the dApp, how can we secure these session keys better? Because we did create a good process of standardizing everything, but we didn't actually protect the key itself. Fortunately, there's a standard today that's widely available in the internet, which is called passkeys. And in order to do that, we have to upgrade the passkeys into using this new standard that's called 7212. And 7212 introduces a new standard that if you look at passkeys, you have this experience that is very widely known. And even whether it's like on Android or iOS, what it uses is that the key doesn't actually exist in the website. Instead, it exists in the secure enclave in your device. And if Ethereum supports the 7212, this means that now we can actually verify the same curve that it's being used for Google Pay or for Apple Wallet. And now the session keys are as secure as your credit cards. And this is currently being considered for inclusion in the next hard fork. So in the next Ethereum upgrade, we might have compatibility with passkeys at the Ethereum level, which is really powerful. So now you might think, is this the end game for wallets? I hope so. Because we went from this path where the authentication lived in the server, and now if the app can act as a wallet, following all of the standards around paymasters and user operations and session key permissions, we can essentially put the wallet in the app, in the user's device, without having the constraint of having to go to the wallet to click and approve and constantly redirect themselves into the wallet. I think that this kind of redefines what's actually being connected, because in the past, Wallet Connect it acted as a protocol between dApps and wallets to interface with each other. But now the definition of a dApp wallet connection is more complicated, and essentially what you're actually connecting is a bunch of infrastructure that's enabling you to have a much better experience, such that you can have less clicks and you have a more redefined wallet experience, which I believe has always been the mission of Wallet Connect. And hopefully we can one day say less clicks is more, and we have achieved the final end goal of Wallet Connect. Any questions?
Yes, we still have some time for questions, so if anyone has any questions, please raise your hands. Yes, gentleman over there.
Hello, thanks for the presentation. Not exactly a question, I'm just trying to see if I followed this correctly. So with this session keys thing, it means that me as a user, I'll go to the dApp, I'm sort of already connected, and then from there I'll give permissions once, and then it uses the session keys to do actions from that moment onwards until I finish those session keys. So I never leave the dApp in the end. Is that right?
That's correct. So if you think about the current experience, going from you go to an app, you see that connect button, you press on it, you go to your wallet, and it says, this app wants to connect to you, but then the app wants to actually verify that you own that account, so they ask you to sign with Ethereum, you sign another message, you go back to the app, but then even after that, once you go through those two steps, you actually still have to go back to the wallet to approve a transaction, and it might be multiple transactions. So you have this constant like going back and forth between two applications to interface, which, doesn't feel great. So in the beginning, you saw that we actually reduced already today with Wallet Connect the connection and the signing with Ethereum into a single step, which was a great improvement, but that didn't stop the wallet from actually having to be redirected every time you need to approve a transaction. So if we want to have a single-click experience for Ethereum, then we need to sign in with Ethereum, and in that message, we need to encode as many information as possible that will delegate responsibility to the dApp to interface. So in these permissions, one of the things that we're working on is that you give a scope of how much the session key can do. So you're not just signing with Ethereum and verifying your ownership, you're also giving an authorization to an app to interface. For example, I want to interface with this smart contract, and it's able to use this amount of assets, and it can call these transactions and maybe do something else. So this session key now not only has an expiry, it could be an hour, it could be a day, depending on how the standards evolve as we build these applications. But in this more modern experience for Ethereum, you basically won't see the approvals anymore, because this key was already constrained to do only a very specific set of methods, and it only has access to a certain assets, and basically they will only use it for their specific application. So now the reason we always redirected users to wallets is because we wanted that consent, but the consent was given up front as to how much scope are you giving this application.
Cool. Thank you. Hopefully that is the end game indeed.
Anyone have any other questions for Pedro? Yes, you, sir. Gentleman at the front. Oh, back there.
Okay, a bit of front running. So, are you thinking of how to visualize the permission that the user is going to give to the wallet, and is it part of this permission standard? How to explain to the user what the exact permissions are and how to translate basically the session key into human readable format?
No. So in the permission standard, the only thing that it's being defined is the actual conditions. So this will be very machine readable, very computer focused. But then what we actually need to create is some standardization around the most common permissions. Similarly to how many transactions today, if you're gonna approve it in a wallet, some of them literally just say, sign contract, and that's all it says. But some more common patterns like approving a token balance, transferring a token, doing a swap, these have become some common that created dedicated user experiences where you actually have a little bit more context about what's happening. So in the permissions, we will eventually have common, allow this many tokens to be spent, allow these many swaps to be done, so you can have very clear scopes around the most common patterns. I guess the open question today is, what about the least common patterns? Do we just straight reject them and don't allow session keys to do these? Or do we allow the user to, kind of explore applications with session keys and then do their own research, At least I think that simple things like swapping and allowing token balances and maybe some DAO voting could already be scoped, because these have been very common patterns that we can standardize the UI for. But it's an open work.
I think we can squeeze one more. Yes, so.
Great talk, and it's very consistent with the one at SafeCon, though I didn't have time to ask at there. And I want to ask, just to clarify a bit, so the session key you were mentioning is mostly for simplifying the usage on dApps, but it won't eliminate the wallet itself, right? Because people still need a place to store their digital assets instead of putting them all on each dApp. So it's mostly for dApps.
The big difference you might see is that at the end of the day, you have, I guess you could call it the signer keys and the session keys, but they're all signers, right? But I guess you could say it there's a primary signer and an app signer, and the difference between the session key is that it has a very narrow scope. there's still a lot of things that you have to do, and you have to consider like the security implications of having a key that can do everything. And this key that can do everything could be adding new signers, approving new apps, changing recovery options, allowing you to top up the balance. You know, you can't just give all the power to these session keys. You still have to have a primary key that has more power over managing your wallet. And another thing that it could also do is potentially even revoke like capabilities from an existing. If, for example, a session key were to be malicious, you can actually have the primary key go revoke that capability, and now all the system will now see, wait a second, you do have this permissions object, but I can see that the primary key has revoked it. So now you can stop that session key from going malicious. So the wallet will still manage your accounts as your primary key, and the session key is just abstracting a set of methods that you can do within this application specifically.
Okay.
Awesome. Thanks, everyone.
Thank you so much, Pedro. Everyone, give a big round of applause for Pedro again.